Well, hello, students. Welcome to X. Welcome to Tesseract YouTube channel. Right? Great. Just give me a single moment. Right? Fine. So I think we are good to go. We are great to go. In fact, right? Fine. So last class, what we have done, we have seen this acceleration time graph we were doing, right? So we have seen what all we can do in acceleration time graph. Now we are going to go for some questions. So before going to some questions, should we do, okay, we'll see some miscellaneous graphs are also there that we'll see at the end, right? So let us do some questions for now. So this part is not required, right? This part I'll delete. Let us see this question. Fine. So we'll see some questions one by one. We try to solve these questions. Right. Okay, great. So this is the first question. This is based on position time graph. Right. Let us see what the question says. So see, the question says the position time graph. The position time graph for a particle moving along x-axis is as shown. So position time graph for a particle moving along x-axis is being shown here, is as shown they are saying. They are asking to find the average speed of the particle between t equal to 0 second to t equal to 8 second. We need to find the average speed of the particle between t equal to 0 to t equal to 8, right? So let us see how to solve this one. Now one thing I would say, this is not a simple question. This requires a little bit of analysis. Analysis is required here to solve this particular question. We need average speed. What is the formula for average speed? Right? I hope you know what is the formula for average speed. So see, average speed is given by, the formula for average speed is total distance traveled. Right? So total distance traveled by total time. Right? Now how to get these values? How to get the total distance traveled here? This is a position time graph. From position time graph we need distance. So you can clearly understand this is slightly different now. How do we get that? How do we figure that out? So see, for that what we can do is, you have to do a little bit of analysis. How to figure out the distance? Means we cannot find area and all. Area will not give you. If you do the final position minus initial position, that will give you the displacement. So final position is 0 at t equal to 8, and initial position is also 0 only, right? So how do we get it? We have to do a little bit of analysis. So for total distance traveled, we have to actually see here, we have to actually understand how exactly the particle is moving, right? So if we see, first the particle goes from 0 to 5, then 5 to 4, then 4 to, no, sorry, position, right? So it goes from 0, just see the position on the x-axis. It goes from 0 to 5, then from 5 it comes back to 0, then 5 to 10, then 10 to 0. So what will be the total distance traveled? So here 5, here also 5, here plus extra 10, and here another 10, right? So how much will become the total distance traveled now? So total distance traveled will become 5 plus 5 plus 10 plus 10, that is 30, divided by the total time, and total time here is 8, right? So 30 by 8 will become the average speed. Now how do we simplify this one? So 30 by 8, so 15 by 4, right? Or I can do it directly also. And also 8 3s are 24, 8 4s are 32 3 times, so 8 3s are 24, right? Then 6 will be left, decimal will come, 8 5s are 40, 8 6s are 48, 8 7s are 56. So 3.75, as I can see from the options, right? So 3.75 meter per second, that means the third option, right? So third option will become the answer here, right? Clear? I hope this is clear. Great. We'll go for the next question now. Let us see this next question. Again, this is another very interesting question. which we will try to solve. This is the question number 2. Right? What does the question says? So the question says the position time graph for a body thrown vertically upward from ground is best shown by which of the following graph shows the position time graph of an object thrown vertically upward from the ground? Which graph shows it the best, right? So how do we figure that out? So see here, okay, so when you throw an object in vertically upward direction, throughout the journey its acceleration will be constant negative. Do not change the sign convention. Generally when we throw an object, what some people do is, suppose this is the object and you throw it like this, then it will go up and come down, right? It will go up and come down like this. Now what we need to do here, it goes up and then comes down. This is what you have, right? Now what we can do, so in this process when it goes up and come down, some people or some students, while going up they take the acceleration as negative, but going down they take the acceleration as positive. Means they are changing the sign convention. So see, we are not supposed to change the sign convention. You have to stick to the sign convention for the complete journey. So if I'm taking upward as positive in general and downward as negative in general, then throughout the journey the acceleration due to gravity will always be acting in vertically downward direction. Yes, sir? Throughout the journey the acceleration due to gravity will always be acting in vertically downward direction. So throughout the journey the acceleration will be a constant negative, right? So for constant negative, how is the position time graph? So we have seen for constant negative acceleration, position time graph will be a downward parabola, because the slope gives velocity should keep on decreasing. So for that happens when the graph is a downward parabola, and for the complete journey it starts from x equal to, position is 0 and finally again it comes back to the ground. So position will become 0 again. So it will be a complete downward parabola, right? So that will make the answer here as option 3. Fine. I hope this is clear. No confusion anywhere. Moving on to the next one. Right. Okay, great. कैसे कहें कैसे हम तो न जानते, right? Question 3. Now let us see this one. What are they saying? Question says a particle starts from rest and accelerates constantly with a meter per second square. So the particle is starting from rest and it is accelerating constantly for some t seconds and then retards uniformly with the same rate, right? It will come same rate till it comes to rest. So it should come to rest, right? The position time graph of the particle is best represented by. So which graph represents this situation the best? That's what the question is asking, fine. So see, when the particle is accelerating, the velocity will be increasing. When the particle is accelerating, the velocity will be increasing. So that means the slope should increase. So for the first part, from 0 to t, the graph should be an upward parabola. From 0 to t, the graph should be an upward parabola, fine. And for the second part, it should be a downward parabola. So first it should be an upward parabola, then it should be a downward parabola. So which option? Because first it is accelerating, then it is decelerating. So upward and then downward. So it's a simple one. You can see in this part it is upward parabola, then this is a part of downward parabola. Here it's the opposite. In third option, first it is downward and then it is upward. For constant acceleration, position time graph will be a curve. It will be a parabolic thing where the slope should keep on changing. So it will not be a straight line. So these two are not at all in consideration also, right? Fine. So here answer will be the first option, because first the slope should be increasing, acceleration should be positive constant. So for that the slope should be increasing. then acceleration is negative constant. So for that the slope should be decreasing. So option 1 becomes the answer here, right? Okay, great. Let us see the next one. Question 4. Again, these are all good questions. They are helpful for JEE, NEET, Mains, Advanced, everything. So don't worry about that. Go through this question, try to understand. I just need some water. Let me sip some water here. Right. Right. So what do we do here in this case? If we are getting some reflection, then we should change the way it sees. Then you will not get reflection, right? Fine. Now I think it's better. Clear. Good. Fine. So particle shows distance time curve. A particle shows distance time curve as shown in this figure. The maximum instantaneous velocity of the particle is around the point. So we need to figure out at which point, around which point the instantaneous velocity of the particle is maximum. Now how do we figure that out, right? So see, we know that, what do we know? We know that slope gives instantaneous velocity, right? We know very well that the slope of the position time graph gives instantaneous velocity, right? Fine. Fine. So I hope this is visible, not an issue. So where will we get the slope? So for velocity to be maximum, we know that the instantaneous velocity is given by the slope, right? Instantaneous velocity is given by the slope. So where will the velocity be maximum? At whichever point the slope is maximum. And at whichever point the slope is maximum, at that point the velocity will also be maximum, right? So Vmax will be at the point where the slope is maximum, right? So for slope to be maximum, the graph, the angle made by the tangent should be the highest, because slope increases with the angle. Tan theta is an increasing function. So if the theta increases, tan theta will also increase. So at whichever point you draw a straight line, and whichever point the angle is highest with the positive time axis, at that particular point the slope will be the highest. Like for example, around A, if you draw a tangent, the tangent will look something like this and will not make a very large angle. Suppose this is the angle at theta A. Now near about B, if you draw a tangent, it will be something like this. So this angle becomes theta B. Near about C, if you draw a tangent, it will be something like this. So this angle will be the greatest, which is theta C. And at D, something like this. Fine. So the point here is that the slope will be maximum near C. Okay, if you draw tangents in C, the slope will be maximum near C. So this diagram is looking very busy. So let me just erase few things, right? So in this case, what happens is that if you are drawing tangents and seeing how the angle is varying, then you will get the maximum angle near C. Fine. So that is where the slope will be maximum. Fine. So here the answer will be third option, which is C, right? Okay, great. Let us go for the next one now. Let us see this question. Question number 5. Right. So have a look what this question says. The question says figure shows the displacement of a particle moving along x-axis as a function of time. The acceleration of the particle is 0 in the region. Right. So they have given displacement time graph and they are asking in which region the acceleration of the particle is 0. The acceleration should be 0. In which region the acceleration is 0. Now again, this is a very interesting question. How do we solve this one? Right. In which region the acceleration will be 0. So see, acceleration is 0 when the velocity is constant, right? If velocity is constant, then the acceleration will be 0, right? Velocity is constant, acceleration will be 0. Now in position time graph, where do we get the constant velocity? So velocity is constant wherever the graph is a straight line, and whichever region the graph is a straight line, the velocity will be constant. Fine. So here you can see in this A to B part and C to D part, between A to B and between C to D, the graph is a straight line. So in these two parts, the velocity will be constant. And the velocity is constant, the acceleration will become 0. So here, this AB and CD. So wherever the graph is a straight line means the slope is constant. That means the velocity is constant because it is position time graph. In position time graph, the slope gives velocity. So if the velocity is constant, acceleration will be 0. So that's that, right? So answer here will become A and C, which is the second option. Okay, fine, great. Let us go for the next one. Again, a very interesting question. This is question number 6. Fine. The question says displacement time graph of a particle moving in a straight line is as shown in the figure. So in this figure you have displacement time graph, and based on the graph we have few things that are being said. So we have to figure out which one is correct or which one is wrong, right? So let us see how to do that. Fine. So displacement time graph of a particle moving in a straight line is as shown in figure. First option says in region A acceleration is positive. So they are saying in region A acceleration is positive. So if acceleration is, so we have to figure out which options are correct, right? So there could be more than one correct answer also. Just saying there could be a possibility. So here which options seems correct? So they are saying region A acceleration is positive. So that seems correct because if you see in region A, the graph, the position time graph, so see whatever characteristics are valid for position time graph, same kind of characteristics are also valid for displacement time graph. Fine. So here for positive acceleration, position time graph should be an upward parabola. So displacement time graph will also be an upward parabola, right? So part A, option A is correct here, right? Option B, it should be a downward parabola. If acceleration is negative, then it should be a downward parabola, basically decreasing slope should be there. So option B is also correct. Option C, uniform motion in the sense the velocity should be constant. So in the part C, the velocity should be constant. So is it constant? Yes. So there is constant. In option D, acceleration is negative. In option D, the velocity is, in the D part if you see, the velocity is negative constant. Okay, velocity is negative constant. So acceleration will be 0. Fine, acceleration here will be 0. Okay, fine. So this is wrong. So here answer, the correct answer will be option A, B and C. Fine. Clear? Okay, great. Let us go for the next one. Which is question number 7. Okay, let us place it somewhere here, no problem. What does the question number 7 says? Okay, let us have a look at it. Right? Question number 7 says that in the figure shown, the position of a particle moving on the x-axis as a function of time. So they are given position as a function of time. Now we need to figure out, what do we have to figure out? So they have given some options. We have to figure out which options are correct or which options are incorrect. Okay, it's as simple as that. There's nothing much there. So you just need to figure out which options are correct and which options are incorrect. So let us have a look. So option A says the particle has come to rest for 6 times. So according to this position time graph, the particle has come to rest 6 times during its motion. Is it correct or wrong? Now, how do we figure that out? So at whichever point the graph, the slope of the graph is 0, at that particular instant the velocity will be 0, because the slope of position time graph gives velocity. The slope of position time graph gives velocity. So at whichever point the slope is 0, velocity will be 0, right? So here at how many points the slope has actually become 0? Let us check that out. So at this point, the bottommost point, at this particular point, right? So at this point, similarly at this point as well, if you draw a tangent, at this point as well, if you draw a tangent, at this point as well, if you draw a tangent, at this point as well, if you draw a tangent. So how many times is that? That is count. So this is 1, 2, 3, 4, 5, 6, right? So 6 times. So the option A is actually correct, right? Moving on to the next option, option B. What does the option B says? Option B says the maximum speed is at t equal to 6 seconds. At t equal to 6 seconds, the speed of the particle is maximum. Is it correct? No. At t equal to 6 seconds, if you see, this is the point corresponding to t equal to 6. If I draw a tangent, because the slope of position time graph gives velocity, right? Slope of position time graph gives velocity. So at this point, if I draw a tangent, the slope will come out to be 0. So the velocity will come out to be 0. So here the maximum speed at t equal to 6 seconds, that is wrong. This is not correct. The velocity remains positive for, right? So fine. So this one is incorrect. Okay. The velocity remains positive for t equal to 0 to t equal to 6. They are saying between 0 to 6, everywhere the velocity is positive. So that is not correct. Because at some point, if you draw a tangent here, like if I draw a tangent here, it will make acute angle with x-axis. If I draw a tangent here, it will make obtuse angle. Here, the velocity is 0. So it's not correct. Between 0 to 6, the velocity is changing the value as well as the sign. At some point, like initially it is negative, then becomes 0, positive, 0, negative, 0, positive, 0, negative, 0, positive, 0, negative, 0, like that. So it is varying continuously, you can see. Fine. So saying that the velocity remains positive for 0 to 6, that is also incorrect. Option D says average velocity for the total period shown is negative. They are saying the average velocity is negative. So that could be true. How to figure that out is, see, average velocity, we are talking about average velocity, not average speed in this case. So let us see. average velocity is change in position by change in time. Average velocity is change in position by change in time, which becomes x2 minus x1. Okay, no problem. Which becomes x2 minus x1 by t2 minus t1. Okay, x2 minus x1 by t2 minus t1, right? So what is the final position? If you see from the graph, finally the particle is here, right? So this is the final position. So x2, let me erase these things, it's creating confusion, right? So what is the x2 value? X2 value somewhere. So see, we cannot exactly figure out what is the x2 value, but one thing we can say that the x2 is less than x1, right? This is x2 and this is x1, right? So x2 minus x1 will be a negative value, and t2 minus t1 though, which is 8 minus 0, which will be a positive value. So negative by 8. So this is a negative value. So this, the average velocity for the total period shown is negative. So this is correct, right? So here the answer will be, what will be your answer? Answer will be, answer will be A and D, right? So A and D options are correct, right? Fine, we'll go for the next one now. Let us see this one. This is question number 8. Now we are moving to velocity time, questions on velocity time graph, right? So until now you must have seen that most of the questions were based on position time graph. Now we are moving to velocity time graph. So that's good, nice, right? Another interesting question. Go through the question, try to understand what it says, right? Question says a body is thrown vertically upward, which one of the following graph correctly represents the velocity versus time. So body is thrown vertically upward. We need to figure out that which of the following graph correctly represents the variation of velocity with time, right? Again, for this question, what happens, many students tend to give which option? Many students tend to give option D as an answer, right? Many students think that the answer will be option D, but answer D is not correct here, right? If they would have asked speed time graph in the question, if they would have asked speed time graph, then option D would have been correct. If they would have asked speed time graph, then option D would have been correct. But in this particular case, they are not asking speed time graph, they are asking velocity time graph. And for velocity time graph, the correct answer will be option C, right? Why is that? Let us try to understand. So we need to plot velocity time graph, right? Now imagine how the particle moves, right? When you project the body in vertically upward direction, initially the velocity is a high value and positive value. So initially the velocity is high and positive, and as it is moving up, the velocity will be decreasing. At the topmost point, instantaneously or momentarily the velocity becomes 0. The topmost point, momentarily the velocity becomes 0 and then starts coming down. Then the velocity starts becoming negative. Yes or no? If you have to stick to the same sign convention for the complete journey. You cannot change the sign convention in between. Some students change the sign convention, they take a different sign convention while going up and different sign convention while going down. You don't have to do that. You have to stick to the same sign convention. Throughout the journey, the acceleration will be in vertically downward direction minus g, which is a negative constant. So if acceleration is negative constant, how will be the velocity time graph? So if acceleration is constant, velocity time graph will be a straight line, and negative constant means it will be a straight line making obtuse angle all the time, right? All the time. So here, this graph will be the answer. This is velocity, this is time, and at any instant the angle should be greater than 90 degree. It should be an obtuse angle. So answer will be option C, which is correct, right? Clear? Great. Let us go for the next one. Now this is an interesting question. This is not position time graph. This is not velocity time graph. This is position time graph only. So let me do one thing. Let me go in sync. Let me move this here. Little bit of rearrangement I'm doing to keep things in a sequential manner, right? So let me make this question. Which question? Let me make this question as question number 9, and let us take this as question number 8, right? Now this is an interesting question. Let us see what the question says. Question says, figure shows the velocity of a particle moving on x-axis as a function of time. How many times the acceleration of the particle becomes 0? So they have given velocity time. Oh, this is velocity time graph only, right? I did not have to do all this. Why did I waste so much time? Right, it's velocity time graph. Oh, I just saw x-axis and I thought velocity time graph. So again, you should also be careful, vigilant, in fact, I would say. That's the better word. Be vigilant, be cautious while solving questions. Right, question number 9. What does the question says? Question says, figure shows the velocity of a particle moving on x-axis as a function of time t. How many times the acceleration of the particle becomes 0? So how many times during the journey the acceleration of the particle becomes 0? Again, we have solved a similar kind of question. Only difference is that earlier we had position time graph, now we have velocity time graph. So in position time graph, the slope gives velocity, whereas in velocity time graph, the slope gives acceleration. So at whichever points the slope becomes 0, at those points the acceleration will become 0, right? So let us see what are those points. So this point is there, right? This point is there, then this point is there, then this point is there, then this point is there. At all these points the velocity becomes, the slope becomes 0. So at all these points the acceleration becomes 0, right? So point 1, 2, the second point, this is the third point, and this is the fourth point. So at how many points the slope is 0? 4 points. So what will be the answer? 4. So answer will be third option, right? Clear? Great. Now you see this question. Next we have the 10th question. Go through the question, try to solve, and I'll come back to this, right? So you have the question number 10. Fine. Okay. Go through the question, try to understand what will be the answer here. Try to figure it out. I'll give you some time. Okay. I'll just take a very small break.